This is the hardware wiring of the elevator's up and down control system that we have connected. After connecting the wires, we need to perform an inspection before powering on. The standard check is for short circuits. We use a multimeter in the ohms range to measure the resistance between each item. Okay, first we measure L1 and L2. Press the start button for forward start, reverse start, and stop. Additionally, the switches forward start, reverse start, and stop all show no signs of a short circuit. At this point, we can conclude that there are no short circuits in the control circuit. Next, we measure the main circuit. The measurement method for the main circuit is to simulate its power on state. First, close the switch. When L1 and L2 have KM1 closed, the resistance is 2000 ohms with no short circuit. The resistance of KM2 is also 2000 ohms with no short circuit. Then measure L1 and L3. When KM1 is closed and KM2 is closed, there are no signs of a short circuit. Finally, measure L2 and L3. When KM1 is closed and KM2 is closed, there are no signs of a short circuit. Based on the measurements above, we can conclude that there are no short circuits in our circuit, and it can be powered on for testing. After connecting the power supply, we must also test the power supply. Only after confirming that the power supply is okay can we proceed with powered testing and debugging. Find the AC voltage range. Between L1 and L2, there is 392 volts. Between L1 and L3, there is 394 volts. Between L2 and L3, there is 394 volts. After testing these three phases of AC power and confirming that there are no issues, we can power on. Forward. Stop. Reverse. Stop. Forward. Stop. Reverse. Stop. Based on the above debugging, we found that the two switches can independently control two contactors. We observed that when KM1 is closed, the elevator goes up, and when KM2 is closed, the elevator goes down. Everyone, this is the elevator up and down control circuit. Have you learned it?